Another constraint you can use, and this one I leave on all the time when I'm modeling, is planar. It's down here in your status line. What planar means is that once I leave my C-plane, like I did just there, the next pick I'm going to use, which should go onto the C-plane, will not actually go on the C-plane. It'll go parallel to the C-plane. Rhino likes to use the word planar to mean a few things. One of those things is to mean flat. The other is to mean parallel. This is planar, or parallel to the currently active C-plane. Come down here and grab on that mid-plane, that mid point of that curve. And since that's on the C-plane, I'll be planar here again. If I go into my right C-plane now and continue to click, theoretically I should go right onto the right C-plane, but I don't. I stay out where I was. I'm just planar to the right C-plane. As soon as I turn planar off, my next pick point, no matter where it looks like I'm putting it, is going to go right back onto that right C-plane. Okay? So, I use planar, I leave it on all the time, because to me intuitively it makes more sense. When I'm drawing, I expect my curves to continue from my last pick point out in three-dimensional space, but planar or parallel to the C-plane. Okay, so that's two ways that you can get your mouse off of a C-plane. You can get it off using an object snap. You can get it off by using planar option on your status command bar. And that's really about it. Now you can type in coordinates. Zero, zero, zero for start of curve. Okay? And these coordinates are entered globally in the order of X, Y, and Z. So if I want to draw a curve all the way out of the end of that red line, that would be 50, 0, 0. Hang on. There we go. Okay. If I wanted it to go all the way out to the end of this green curve, that would be 0 in the X direction. Oh, I wish it would stop doing that to me. Let's try again. This is not a typical way to work in Rhino, so in the Y direction, 0 in the Z direction. Okay? I could, if I wanted to, enter coordinates in the Z axis on the top C plane. Sorry. There. Okay. And then if I wanted to, I could enter back over to the far right. I could then come back directly underneath. So that would be 0, 0, minus 50. All the way over to the far left now would be minus 50, 0, 0. Back up to the top would be 0, 0, 50. And then back down to where I started would be 0, 0, 0. So that's the other way you could get your marker to go up and off of the seaplane. But really, practically speaking, the only way this is going to happen is if you are using an object snap. Okay? So that should give you some idea of how a seaplane works and what it is. The next question that will come up is why. I'm going to turn back on the grid axis again. I'm sure you'll get that from here. Okay. By the way, even when it's off, over here in the corner, there's always a little grid axis icon that shows you global coordinates, X, Y, and Z. And you can see it matches. Red is X, green is Y, Z is blue but invisible. If I go to the front seaplane, X is red. This is showing as Y, which is green, which is correct for local coordinates. But on the global here, you can see it's actually would be blue or Z. Okay. All right. Why would you make a custom seaplane? Okay. An easy way to explain this would be to make a prong wire, a very simple prong wire. Okay. For ease, I'll put it out here. Okay, so what we have is a diagonal wire going up into the air, like you would for a prong. And it's going to be pretty thick, but we'll call it 2 millimeters. Alright. So there's a piece of pipe. You could call it a prong if we want to. Alright. What if I want to scale this pipe in diameter, but I want to keep the length the same? Okay, the command for that in Rhino would either be a non-uniform scale or a 2D scale, because a 3D scale, it's not going to work. A 3D scale is going to make the whole wire smaller. Let's say I even know how big I want to make it. I want to make it 1 millimeter. So in the command line I can type in that equation, 1 divided by 2. Well, that is now 1 millimeter in diameter, but it's shorter. I can't work with that. Okay? And let's say that it's really important to me that it doesn't move at the top. Normally when you're doing a scale, your origin point is the thing you don't want to move, to change. So pick the center, type in the same equation, or just accept 50%. Well, yeah, there's your diameter, but you've lost the length. Okay? So let's try that from another seaplane. Front seaplane. Maybe that'll work. No, it didn't. Let's try right seaplane. Now, I'm being a little silly because since it's a 3D scale, It's going to be the same regardless of what C-plane I'm in. It's going to revolve. It's going to scale everything, 50% in all directions. So it doesn't matter what C-plane I'm in. But let's say I'm going to try and do this now with a 2D scale, so we don't change the length. That's clever. I like that. Right click on our 2D scale here on our scale button. Snap to the center. 50%. Oh, hang on. I didn't have that set to 50%. Perfect. See what happened? I did keep the same length, but it skewed the geometry because it's thinking 50% from the top. It's doing it all from this direction. Now that didn't work. How about front C-plane? I'm going to change the color of this layer so it's a little easier for us to see. Beautiful. Skewed again. And I'll bet you can guess what's going to happen if I go into the right C-plane. Same thing. It even lost length because it's projecting it onto the right C-plane. Everything is thinking in terms of that right C-plane. So you have a problem. Okay? Now, some advanced Rhino people out there will go, well, what if I project it to the C-plane? This will project my pick points so they don't go out into three-dimensional space. See, it projects it down. Well, that's not going to work because, for one thing, it's going to change where it scales around. But it's going to also give you the same problems. Okay? Can't be done. Alright? Now, I'm sure that somewhere in the listening audience we have an advanced Rhino person who will say, well, I don't have to do any of that. I can just explode this out duplicate the borders. I don't even have to duplicate the borders. I can just scale each one of these. Scale 3D this time. And then a loft in between them to reconstitute the shaft of the wire. Excellent. That worked. Gave you exactly what you wanted. But that's not the point of using a scale transform. Okay? I specifically said scale. If you have to remake geometry whenever you want to do something that your lack of understanding of C-planes makes it hard for you to do, and believe you me, there are a lot of modelers who do exactly that, who prefer just to remake things rather than try and deal with the nightmare of a C-plane. C-planes are not a nightmare. Be aware that you're using it all of the time. You can't not be using a C-plane in Rhino. You have no option. The only question is, which one are you using? So, embracing C-planes and refusing to reconstitute the model. What we're going to have to do is we're going to have to set a C-plane to something else. What we want to change is the diameter. So if we can set a C-plane to this face, we should be able to do a 2D scale without affecting anything else but the diameter. So picking that top surface and doing 2D scale, we'll achieve exactly what we want to do. And it's the only way we could have achieved what we wanted to do. Okay? Another example. What if we wanted to do an interesting shape for our end section here? I want to draw a different kind of cross section on here. Okay? So I'm going to come in here, duplicate my border so I have an example of where it is. I want to do a different cross section for both one of these. For each one, a different cross section for each one. Okay? Perfect. So all I have to do now is just draw my new cross section. I want my new cross section to be kind of a soft triangle shape. I know exactly what I want it to be. So I'll just line it up so I can see it. And I'll use a near snap. Yeah, I'm not going to cheat. I'm not going to use snaps. No. No snaps for me. I'm just going to draw it. This is nice. Not being too fussy because I want it to be organic. And I've got this one down here so I can see how big it needs to be. So I'm going to draw a little bit different, kind of a twisting thing. A little different triangular cross section down there. Perfect. See where they ended up? On the top C-plane. Well, that doesn't work. So, certainly one of my other views will have it, so I can do it. Has to. Because Rhino wouldn't be so rude as to force me to do something unusual. Okay. It's not perfect, but it's pretty good. It's pretty good. I can guess. I can get it pretty close here. And that got really hard last time, so I'm not even going to try and do the perspective thing this time. I mean the twisting thing. I'm going to just draw a nice triangle soft thing here. There, I like that. That's perfect. Okay? Except for it isn't. It drew them both on the top C-plane. No, that didn't work. Let's go for front. Front's going to be better. That was stupid of me because top and C-plane and the perspective viewport, it's the same thing, but this is different. This is front C-plane. This will certainly work better for me. And I hope you're picking up on what I'm saying here. Perfect. Not so much. Both of those shapes are flat as a pancake on the front C-plane because that's what front view means. Front view means front C-plane. That's all it means. It means front C-plane with a perpendicular camera. So, the challenge I face is the only way to draw this freeform shape is to set a C-plane. Set C-plane to object, pick that end cap, draw my soft organic triangle shape, whatever. And it's right where it's supposed to be. Same thing down here. oriented the same way, so I'll zoom out so I can see the other one. Right where I need it to be. Something that I could not draw any other way. And I could waft those, make a simple surface, and have this kind of wabi-sabi organic pipe. Okay? So, I hope you're seeing how this works. You have to be able to have the power to create a seaplane in order to draw and transform wherever and in whatever orientation you need it to be. Because how often in Rhino do you think that your geometry is going to be flat top, flat right, flat front? I mean, really. Flat right, flat front, flat top. For organic jewelry sorts of modeling, very rarely are you working with one of those views when you're trying to draw or create something. Okay? There are workarounds. You can work flat and then flow things into place. It's what a lot of people depend on. But if you have to work by hand, if you have to go in and hand cut, shape, strip, form, you have to go work modeling in situ, you have to know how to use seaplanes effectively.